The Cold War, a time of secrecy, high stakes, and technological marvels shrouded in mystery. Today, on the Tech Insider, we unveil the legend of the SR-71 Blackbird. This wasn't your typical jet fighter. It was the sound barrier at 3 times the speed of sound. Imagine soaring through the stratosphere, gathering intel unseen, a symbol of power and technological prowess. But what made the Blackbird tick? What kind of engineering genius went into crafting this supersonic marvel? Join us as we on a mission to unravel the Blackbird's legacy. The Blackbird's secrets await. Let's unlock them together. The Lockheed SR-71 Blackbird, an engineering marvel, redefined the boundaries of aircraft design. Developed by Lockheed Corporation during the Cold War, this long-range, high-altitude Mach 3+ strategic reconnaissance aircraft was designed to streak across the sky at 3 times the speed of sound, over Mach 3.2 at altitudes up to 26,000 meters. This incredible speed made it extremely difficult for enemy defenses to intercept or engage the aircraft effectively, making it the fastest jet in the world. It could survey 100,000 square miles per hour, and the SR-71 almost touched space. Its advanced design allowed it to outfly and outmaneuver any enemy threat, gathering critical intelligence for over 2 decades. The SR-71 stands as a pinnacle of aviation technology and a symbol of American ingenuity. The SR-71 was developed as a black project from the Lockheed A-12 reconnaissance aircraft during the 1960s by Lockheed's Skunk Works division. President Eisenhower tasked Lockheed Martin with creating an aircraft that could outperform existing reconnaissance planes in speed, altitude, and stealth capabilities. The SR-71 first took to the skies in April 1962 and entered service with the United States Air Force in January 1966. Exterior design and size. The shape of the SR-71 was based on that of the earlier Lockheed A-12 reconnaissance aircraft, one of the first aircraft designed with a reduced radar cross-section in mind. The Blackbird's fuselage was designed to be long and slender, with a 1.7 aspect ratio wing. The aircraft's Chinese mean the sharp leading edges of the fuselage and wing edges were made from plastic materials that conformed to local aerodynamic and thermal load limits. The SR-71's black paint incorporated a special radar-absorbing element to reduce the amount of reflected radar waves. The SR-71 was a large aircraft, measuring 107.4 feet in length, with a wingspan of 55.6 feet and a height of 18.5 feet. Jet engines and nacelles. The SR-71 was powered by 2 Pratt & Whitney J58 turbojet engines, which were housed in distinctive engine nacelles. These nacelles, along with the air inlets, contained advanced technology that allowed the aircraft to reach its maximum speed of Mach 3.2. The Pratt & Whitney J58 engine was a dual-cycle engine, operating as a standard after burning turbojet at subsonic and transonic speeds and switching to a ramjet-like behavior at around Mach 2. The engine provided more than 2,000 pounds of thrust at sea level. The engine nacelles also featured a spike that moved to optimize the shock waves and maintain optimum performance at different speeds and altitudes. The SR-71 Blackbird's powerful J58 engines required specialized start carts, known as the AG-330, to ignite during takeoff. Each cart housed 2 Buick Wildcat 401 cubic-inch V8 engines, generating 400 horsepower each. This combined power drove a shaft connected to the SR-71's engines, providing the initial boost needed for takeoff. The inlet spike. The inlet spike was crucial for the Lockheed SR-71 Blackbird to achieve its exceptional supersonic speeds. Positioned at the front of each air inlet, it managed airflow by moving inward up to 66 centimeters as the aircraft exceeded Mach 1.6, directed by an analog air inlet computer. This movement brought the shockwave closer to the inlet cowling, minimizing airflow spillage and reducing drag at supersonic speeds. Flight control surfaces of the SR-71 Blackbird. The Lockheed SR-71 Blackbird used elevons for flight control, combining the functions of ailerons and elevators. Located along the wing's trailing edge, these surfaces controlled both pitch and roll, enabling precise maneuverability even under extreme supersonic conditions. Airframe and heat management of the SR-71 Blackbird. The SR-71's airframe was primarily constructed from titanium alloys, making up 93% of its structural weight, to handle the intense heat of Mach 3+ flights. Aerodynamic friction and engine operation caused temperatures up to 565 degrees Celsius, with average surface temperatures between 239 and 328 degrees Celsius. The fuselage panels fit loosely on the ground to allow for thermal expansion during flight. The cockpit's outer windscreen, made of quartz and fused to the titanium frame, could reach 316 degrees Celsius. Cooling was managed by cycling fuel behind the titanium surfaces in the Chinese. The cockpits of the SR-71 Blackbird. The SR-71 had two cockpits, one for the pilot and one for the reconnaissance systems officer, RSO. The pilot's cockpit featured a comprehensive array of instruments and controls for managing high-speed, high-altitude flight, including an attitude indicator, horizontal situation indicator, HSI, and a map projector display. A triple display indicator provided precise readings of knots equivalent airspeed, KES, altitude, and Mach number. The pilot controlled the engine inlet spike position, bypass doors, and other engine systems, and had a stick pusher or shaker switch to prevent exceeding the critical angle of attack. The RSO's cockpit, located behind the pilot, contained controls and displays for the SR-71's advanced reconnaissance systems. The aircraft had equipment bays with systems for optical or infrared imagery, side-looking airborne radar, SLAR and electronic intelligence, ELINT gathering. These systems enabled the capture of detailed images and data from high altitudes. Both crew members wore pressure suits similar to those worn by astronauts to protect against sudden cabin pressure loss at high altitudes. Throughout its nearly 24-year career, the SR-71 Blackbird held the titles of the world's fastest and highest-flying operational aircraft. It flew numerous missions over Vietnam, North Korea, and Iraq without ever losing an aircraft to enemy fire, playing a crucial role in Cold War reconnaissance. Despite its remarkable performance, the United States Air Force retired the SR-71 in 1989, primarily for political reasons, though some were briefly reactivated in the 1990s before final retirement in 1998. Since retirement, reconnaissance roles have been filled by satellites and UAVs. Lockheed Martin is developing the SR-72 as a potential successor, anticipated to fly in 2025. The SR-71 was a technological marvel that pushed the boundaries of what was possible. Its legacy extends far beyond the Cold War, inspiring future generations of engineers and dreamers. Here at the Tech Insider, we hope this glimpse into the Blackbird's wonders has fueled your curiosity. If you enjoyed this video, be sure to leave a like and subscribe to the channel for more explorations into the fascinating world of technology. Until next time, keep on exploring.